Kia ora, I'm Eleanor. Thanks for joining me for the second part of this series on using DNA to Whakawhanaungatanga, make connections. If you haven't watched part 1 yet, I encourage you to go back and watch that talk first. Most of this presentation will be in English, but there will be some kupu Māori words. You'll find a glossary of these in the handout. Please keep in mind that the information on DNA testing companies' websites is updated frequently and may have changed by the time you're watching these videos. All information presented here was up to date as at December 2020. In this talk, I'm going to step through how to identify the matches at family tree DNA who share recent common ancestors with you. In part 3, we'll look at how to do this at Ancestry. It might surprise you that I'm starting with family tree DNA because not so many people have tested there. That's a shame because family tree DNA has some great tools that are perfect for what we're trying to do. If you haven't tested at family tree DNA and you want to take advantage of these tools, you can transfer a copy of your raw data file from Ancestry, MyHeritage or 23andMe since November 2013 to family tree DNA for free. You'll be able to see all your matches. You can then pay a one-time fee of US $19 to access all the tools. I highly recommend transferring to family tree DNA because you never know where your best matches will have tested. And in this database, you get to use a range of tools that are very helpful. Always check the terms of service before uploading to be sure you're comfortable with them. As we saw in part 1, as Māori, we may face extra challenges when using our DNA test results to Whakawhanaungatanga because of the mismatch between the DNA testing company's expectations about DNA inheritance and the history of Polynesian migration to Aotearoa, New Zealand. There are particular challenges if you have one or more Māori great-great-grandparents. One strategy is to focus on matches who most likely share recent common ancestors with you, but it isn't as simple as starting at the top of your match list. One technique we can use to find these matches is to look for the matches who share long blocks of DNA with us. Essentially, before you go and start working out how your DNA matches are related to you, you need to first go through the default match list you've been given and create a custom-built list of your top matches. So just to recap, the reason why we need to do this is because with Māori and Polynesian matches, you're more likely to share more DNA with them than what the DNA testing companies expect. So instead of having a smallish number of close matches who share lots of DNA with you, you may have hundreds or even thousands of close matches. And while they'll still share lots of DNA with you, most of them won't actually share recent common ancestors. Luckily in part 1, we saw that the people who actually do share recent common ancestors won't just share a lot of DNA with us, they'll also share large segments of DNA. So no matter where we test, our first task is to find the matches with whom we share large segments of DNA. By now, you're probably wondering, okay, well, what's a long segment? Well, thanks to the hard work of lots of people, and in particular for Polynesian DNA testers, the work of Kalani Mondoi, admin of the Polynesian DNA project at Family Tree DNA, the recommendation is to find matches who share at least one segment of 30 centimorgans or more. Once we've done that, we then need to look more closely at each of these matches to find the people who also share at least a few other large segments as well. Depending on the DNA testing companies, there are different ways to work out this info. These people will be your priority matches and they will go in your custom-built match list. You can think of these people as the matches who would be at the top of your match list if the match lists were built for people from communities impacted by founder effect and endogamy. Out of all the people who share large amounts of DNA with you, these matches who share a longest block of 30 centimorgans or more, plus some other long blocks of ideally 20 centimorgans or more, will be the matches who most likely share recent common ancestors with you, RCA. Obviously, you're always free to look at all of your matches, but we just recommend that you start your research with these people. It's going to be easier, faster, less frustrating, and probably more rewarding, because it'll be easier to find who these recent common ancestors that you share with these matches are. So no matter where you test, finding matches who share multiple long segments of DNA with you is the key to finding matches who most likely share recent common ancestors. Now, before you race off to get started, it's also really important to know that this is just one of the steps in this alternative research methodology. At the end of part 3, I've provided an overview of all the steps, and in the handouts there are links to places where you can find more information. With that said, let's jump in and see how Family Tree DNA can help us. First off, Family Tree DNA can help us because you can sort by longest block. The segment detail is available, and you can upload if you haven't tested direct. You can also add on Y-DNA and mitochondrial DNA tests. I don't have time to talk about them here, but they can be helpful, and Family Tree DNA is the only place where you can take these tests and be compared in a large matching database. Family Tree DNA also have projects that you can join. So that's a bit of an overview for now. Let's take a look at the process at Family Tree DNA. We need to start by sorting our match list by longest block. We want to be looking out for matches who share long blocks of 30 centimorgans or more. Next, we want to view the segment data. This is so we can see what is the size of the other segments. We can filter out all the small segments of DNA, which are more likely to come from more ancient tupuna, to get a new, smaller total that just includes only the longer blocks of shared DNA. We can then use the shared centimorgan tool at DNA Painter to generate more accurate relationship predictions. So let's now look at a few matches. Here we have two matches who both appear to be very close relatives of the tester. The predicted relationships are pretty much the same. We can also see that the shared centimorgan, the total amount of DNA they share with the tester, is almost the same. Let's take a look at Family Tree DNA's chromosome browser to see what more we can learn about these matches. On the chromosome browser, we can see that the tester and their first match share many small segments of DNA. These are the small blocks in blue. This gives us an overall impression of the match, but the information shown on the chromosome browser is not entirely to scale. So you do need to look at the segment data for each match to get the full picture. I'll show you the different ways to get the segment data in a minute. In this case, I've already checked the segment data for these matches and found that this is the longest block. Now let's look at the second match. Straight away it looks quite a bit different, and not just because the blocks are in red. Even though we know the browser isn't to scale, there's a clear difference between this match and the last one. There are fewer small segments of shared DNA, and there are also some very large segments. Like last time, I've downloaded the segment data to check it out. And as you probably guessed, this is the longest block. We can really see the difference between these two matches if we look at them side by side in the chromosome browser. If we zoom in to look at a few of the segments more closely, we can also see a big difference between long red blocks and lots of very short blue blocks. Coming back to the match list, we can see that on the far right there's actually a column called longest block. This is what Family Tree DNA calls the longest segment. So even without looking at the chromosome browser, if we can compare the numbers in this column, we can see which match shares the longest segment of DNA with the tester. Kanaka Māori and the tester share a 23 centimorgan block, while the longest block Honiamete shares with the tester is 93 centimorgans. This is considered to be a very long block. As we saw in Talk 1, matches who share long segments of DNA are more likely to share recent common ancestors, and earlier on I said we're looking for matches who share blocks of 30 centimorgans or more. This means that out of these two matches, hone is most likely to share a recent common ancestor, such as a grandparent, and therefore could actually be the tester's first cousin. Just in case you're thinking, well, there can't really be that much of a difference between these two, let me just put this in perspective. While hone might share a grandparent with the tester, the other match, Kanaka Māori, is actually from Hawaii. So the shared common ancestor probably lived around 800 years ago, or maybe more. The likely relationships for the tester and Kanaka Māori are probably 30th cousins, in maybe 20 different ways. I hope this gives you a bit of a sense of why I recommend looking for matches who share long blocks of DNA with you. You could spend an awfully long time trying to figure out how you come to have a Hawaiian first cousin without ever finding the answer. Meanwhile, a match who actually shares a great-grandparent or closer could be just further down on the match list. And all you have to do to find them at Family Tree DNA is click on the longest block. So I've done that here. By default, your match list at Family Tree DNA will be organised by shared centimorgan. That's the column to the left of the longest block. I recommend you order your match list by clicking on longest block every time you look at your matches at Family Tree DNA. So the matches who share the longest block of DNA with you will be brought to the top of your match list. It just makes it so easy to find the matches who share a longest block of 30 centimorgans or more. And for this example, it's these matches here. Next, you want to check how many other long blocks you share with a match, and also adjust the total by removing small segments. We can find the segment info by looking at the chromosome browser. Before clicking on the chromosome browser though, you need to first choose the match or matches you want to look at. We're actually going to go back and look at the Kanaka Māori match again, even though the longest block is less than 30 centimorgans, because we just want to see how many blocks, 15 centimorgans or more, are actually shared with that match. Research indicates that matches who share a block of 15 centimorgans or more definitely share a common ancestor at some point back in time. So let's go back to our other tester. I've left the match list unsorted, so that's why the Kanaka Māori match is still at the top. We need to first tick on the box to the left of her name. This turns the match yellow. Next, we click on the chromosome browser. That will take us to this page. We saw a version of this earlier. We're looking here at just the top part of the chromosome browser. At the top, there's a filter automatically set to show all segments over 5 centimorgans that you share with a match. As we are looking for matches who share large segments, we can adjust the filter to the highest level, which removes all segments 10 centimorgans and under. This can be a really quick way to get a better idea of whether the match is likely to share a recent common ancestor or not, if just looking at the longest block column didn't give you enough of a clue. But first, let's look back at the Kanaka Māori match with the filter set to 1 centimorgan, so we can see all the matches. Sorry, we can see all the segments. So here it is, lots of little segments. And just a reminder, this is where the centimorgan total comes from and where the predicted relationship comes from. It's all these little segments added together that creates a big total and tricks the DNA testing company into thinking that the tester and match share a recent common ancestor. Let's now set the filter to show only segments longer than 10 centimorgans. You can see there are hardly any segments left. From this page, if you're interested in clicking on the length of one segment, you can simply click on a segment and you'll get a pop-up box which gives you that information. You also have a couple of options of viewing all the data. One of them is to click on View Segment Data. Another way you can access all segment data is from the top of the chromosome by clicking on Detailed Segment Data. This will show you the information in the website, the same as clicking on View Segment Data. And the other option is to click Download Segments. With this option, you'll receive a spreadsheet file. You can open this in a program like Excel or Google Sheets. Let's have a look at one of the things we can do with the detailed segment data. This is some of the detailed segment data from the Kanaka Māori match. I've sorted the data by centimorgans, so I can easily see the longest blocks of DNA that the tester and match share. When you're looking at the data like this, you can choose to raise the threshold for a valid segment even higher. And as I suggested, let's look at a threshold of 15 centimorgans. Looking at this match, there are only 2 segments that are larger than 15, and none are larger than 30, as we already know. So you can add up these segments though and get an adjusted total. If you add up the 2 segments here, you get a total of 40 centimorgans. Another way of adjusting the total is to copy and paste the segment data into the individual match filter at DNA Painter. Just click on the box to go to the tool. Paste in your segment data in the box here. Remember to adjust your threshold here. The default threshold is 7 centimorgans. I've chosen 15 centimorgans as the minimum threshold. You definitely want to choose a threshold of at least 7 centimorgans. One more thing before we leave this slide is that there's a really great video that you can watch for more information about how to use this tool and how to get your segment data from the different companies. Just click here. Okay, so let's enter our data. Here's the result, the same as what we got from doing the maths ourselves. We get the average segment data as well. And that can be other useful info, but we're not going to look at it right now. From here, we put this adjusted total of 40 centimorgans into the shared centimorgan tool at DNA Painter to generate adjusted relationship predictions. This tool is not designed to be used with matches that you know share multiple common ancestors and therefore multiple relationships with you. The estimated relationships could still be way out, but we're using the adjusted total based on only the segments 15 centimorgans and up. So the predicted relationships for Māori or Polynesian matches should be more accurate. We just need to click on the green box to go to the tool. Here I have entered the adjusted total of 40 centimorgans. Scroll down and you'll see this. The predicted relationships at DNA Painter when a match shares 40 centimorgans. There's a lot of info on this slide, but there's just a couple of important things to take away. First, the closest predicted relationship is a half-second cousin, which would mean that the match shares one great-grandparent. There's only a 4% chance of that being the correct relationship though. It's much more likely that the most recent shared common ancestor was around a great-great-great-great-grandparent or more distant. There's a 48% chance of this. Adding in the other information we know about this match, the estimated relationship based on the adjusted total now fits more with the match's family history. As I mentioned earlier, this tester is from Hawaii with no known connections to Aotearoa. She knows her genealogy and many of her family have DNA tested. All their results support their known family tree. So the most recent common ancestor is likely to be from before Waka left Central Eastern Polynesia for Aotearoa about 700 to 800 years ago. You can see that one of the most likely relationship predictions includes an 8th cousin or more distant. So that's probably where the relationship with this match fits, as a distant cousin, perhaps a 30th cousin, but in many, many different ways. If you scroll down the page, you can see the predicted relationships option in a chart view. When you and a match share 40 centimorgans, there are lots of possibilities. I've highlighted the half-second cousin relationship on the left and the 8th cousin relationship bottom right. You can see that none of the close relationships in the centre are highlighted. So this is more evidence that despite sharing a large total of DNA and being a predicted close relative, once all the small segments are removed, the predicted relationships point to the tester and match being much more distantly related. And if we look at the 2 relationship predictions side by side, on the left from Family Tree DNA and on the right from DNA Painter, we can see that there's no overlap between the 2. So this is just really to illustrate what a difference it makes when you remove those small segments under 7 centimorgans, and in this example we removed all the small segments under 15. Let's quickly look at the difference for Hone, the second match, who shares long segments with our tester. What changes would we see for him if we remove the small segments? We'll look first at all the segments on the chromosome browser. And so we can see long blocks and also quite a few small ones. Now when we adjust that filter for a quick view to show segments longer than 10 centimorgans, all those little segments drop out, but we can still see those long segments. So we can be fairly confident that he shares a recent common ancestor with our tester. Let's now look at this detailed segment data. So here we are, and you can see there are many segments 15 and greater. So again, there's a very big difference between these two testers. And that's telling us Hone is a priority match for this tester at FamilyTreeDNA. So a few tips for working with your matches at FamilyTreeDNA. Number 1, reorder the match list by longest block every time before you scroll through your match list. 2, recalculate the total by removing small segments at least under 7 and perhaps even up to under 15. Next, use the shared centimorgan tool to generate relationship predictions that are more likely to be accurate. To summarise, matches at FamilyTreeDNA who share at least one segment 30 centimorgans or longer, plus several other blocks, ideally 20 centimorgans or longer, are the matches most likely to share recent common ancestors with you. RCA. I know there's been a lot to take in over the series, and we've only covered one of the 4 DNA testing companies. The videos are going to stay up online, so you'll be able to come back and watch them again if you want to. The most important thing to take away from this talk is that segment length matters. I can't 100% guarantee that you'll share a recent common ancestor with all your priority matches, but they are the matches who will most likely share recent common ancestors with you, or be the matches that will most likely help you find the most recent common ancestors. I'm not saying ignore the matches who only share small segments or small totals, but it will be much more difficult to work out the common ancestors for those matches. Well, that's part 2 complete. Next up is Ancestry in part 3. Thanks so much for joining me. I hope you found part 2 useful. If you use Facebook but you've not already joined any specialist DNA help groups or FamilyTreeDNA projects, you might want to join some. You'll find links in the handout, and you'll also find links to more information about the impact of founder effect and endogamy on DNA test results in general. Thanks again for joining me, and thanks to everyone who's contributed both directly and indirectly to this presentation. And a special thanks to ROOTSTECH for putting on this amazing event.